Logarithmic graphs. Before we get into the graphs of logarithms, let's review your graph of exponentials. Y equals 2 to the x, 3 to the x, e to the x, 0.6 to the x. They all have the same domain and range, and they all have the same horizontal asymptote. So we're going to stick with 2 to the x because 2 is an easy number to deal with. So domain is going to be all real numbers. Range is y is greater than 0. And we have a horizontal asymptote at y equals 0. Okay, and let's write down some parent points just to help us out. So some parent points would be -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Those are some parent points. If I ask you to find the inverse of y equals 2 to the x, so the inverse of y equals 2 to the x. You want to find the inverse of any function, you switch x and y. So the inverse of y equals 2 to the x is x equals 2 to the y. Switch x and y, therefore you would switch domain and range. The domain of this function becomes 0 to infinity. The domain of x equals 2 to the y is the range of y equals 2 to the x. So the range of y equals 2 to the x, 0 to infinity, is now the domain of its inverse. The range is now going to be -infinity to infinity. And instead of having a horizontal asymptote at y equals 0, we now have a vertical asymptote at x equals 0. Okay, so why are we finding the inverse of y equals 2 to the x? All right, well, I will tell you. This right here is considered exponential form. When you find an inverse, you switch x and y, and then you solve for y. We don't leave it as x equals 2 to the y. We now need to solve for y. Well, how do I do that? I use logs. This is exponential form. Let's convert it to log form. X equals 2 to the y in log form is y equals log base 2 of x. Exponential form, log form. Okay, so let's put it together. I started with y equals 2 to the x. To find its inverse, I switched x and y. To solve for y, these are the same. X equals 2 to the y equals log base 2 of x are the same. They're just written in different forms. It's like saying 5/3 is the same as 1 2/3. They mean the same. One's an improper, one's a mixed. They're the same. Well, these are the same. Y equals 2 to the x equals 2 to the y are inverses. Y equals 2 to the x, and y equals log base 2 of x are inverses. Transitive property, if A equals B and B equals C, then A equals C. I think that finding inverse points can be difficult. So what I do is I kind of know my parent points off the top of my head, and I think you do too. If x is -2, you get 1/4, and you can construct these pretty quickly off the top of your head. I'm pretty confident about that. Well, how do you find an inverse? Switch domain and range, switch x and y. Well, let's switch x and y of our points. So y equals the log base 2 of x. My parent points are going to be 1/4, -2. 1/2, -1. 1, 0, 2, 1, 4, 2. Those are going to be your parent points. Do a quick little sketch. Natural log would have base e So instead of being 1 over 4, it'd be 1 over e squared, which you would need your calculator to figure out. Okay, my domain, let's actually rewrite it down here. Put it in one big box. The domain is 0 to infinity, which we already knew. The domain, the argument must be greater than 0. X must be greater than 0, 0 to infinity. I'm just rewriting. The range is negative infinity to infinity, and the vertical asymptote is x equals 0. So I'm just going to kind of circle this. And then, of course, we'll draw the graph. 1/4 negative 2, whatever. 1/2 negative 1. 1, 0. 2, 1, 1, 2, 3, 4, 4, 2. Hey, that's pretty good for me. And then draw in your vertical asymptote. Y equals log base 3 of x is very similar. They all go through 1, 0, but instead of going through 2, 1, it goes through 3, 1. And then it goes through, instead of going through 4, 2, it goes through 9, 2. So we're going to shift this function just like we do all the other ones. If you can remember that the shifts are determined the exact same way, the only difference is the shape, you're going to be good to go. All right, so let's graph and then determine reflections, et cetera, et cetera. Use a darker color. So let's graph f of x equals 1 minus 2 is log base 2 of 3x minus 4. I'm sticking with base 2, it's just easier to work with. Okay. You're going to determine the shift exactly the same way as if it were a parabola or if it was a root function. If I gave you, so for example, a little side note here. If I gave you 1 minus 2 times the absolute value of 3x minus 4. Oops, that's supposed to be absolute value bars, sorry. That looks really funny. This is a reflection over the x-axis, up 1, multiply your x-coordinates by 1/3, and it's a shift right 4/3. The exact same thing is true. I gave you the f of x is equal to 1 minus 2 times the quantity 3x minus 4 squared. Same exact shifts, same exact reflections. It would be the same if I gave you a rational function. 1 minus 2 over 3x minus 4. This one's a v, it's absolute value. This one is a parabola, it's a u. This one has branches with asymptotes. So we are going to determine our shifts exactly the same. Okay, so this is up 1. The negative 2, this is a reflection over the x-axis. The 3x minus 4, this is a shift right 4/3, not 4. 3x minus 4 equals 0. So if you still have that question, what quantity of x makes, what value of x makes the quantity 0? That's positive 4/3. This is a shift right 4/3. All right, and then I have the coordinate of x is going to be multiplied by 1/3. The a value, so to speak, that your book talks about. The coefficient on x is, in this case, 3. So we are going to multiply by 1/3. All right, not only is this a reflection over x, This is going to be a compression. This is going to be a compression. So all in all, when I reflect over x, this means that my y values are going to be multiplied. Sorry, this is terrible handwriting. Multiply y by -2. Parent points. So for a log graph, the exponential goes through to 4, so the log goes through 4, 2. Exponential goes through 1, 2, so this goes through 2, 1. 1, 0. 1/2, -1. 1/4, -2. Okay, so those are your parent values. If it helps you, write the exponentials off to the side and then flip them, or memorize the log ones, whatever. Doesn't matter how you do it. Okay, up 1, reflection over x. So I'm going to take care of my y values first. So I'm going to multiply my y values. Multiply, then add, order of operations. Multiply by -2, and then add 1. So 2 times -2 is -4, plus 1 is -3. Okay, and then I'm going to pause the video here. You go ahead and figure out the remaining points for y. So you should have gotten, for your y values, -3, -1, 1, 3, and 5. How did I do that? I multiplied my y values, my parent y values, times -2. Up 1 means add 1. Okay, the x's are not quite as nice because you have this horrible fraction, but I'm going to multiply my x's by 1/3, and then I'm going to add 4/3. I'm going to multiply x by 1/3, and then I'm going to add 4/3. So 4 times 1/3 is 4/3, plus 4/3 is 8/3. 2 times 1/3 is 2/3, plus 4/3 is 6/3, also known as 2. Pause the video, you figure out the remaining x values. These are your official points. Not necessarily pretty, but it is what it is. And I need to find my domain and range. I skipped that. Let's find our domain and range. Okay, so the domain, sorry here. The domain argument is 3x minus 4. So for my domain, 3x minus 4 needs to be greater than 0. So x is greater than 4/3. Yeah. My pen just ran out of ink. Let's try that again. There we go, much better. So I'm going to have 4/3 infinity. Maybe this is a reflection. You have to be careful. Reflections can change domains and ranges. So we may have to come back and fix this. The range is all real numbers. And my vertical asymptote is going to be at 4/3. I haven't graphed it yet. I think 4/3 infinity might be backwards. Let's see. So go ahead and sketch the graph. There's your graph. Not super pretty, but it does the trick. So the question I'm sure you're wondering is, how far down does it go before it starts to, like, not bottom out, what's the right word? Before the curve starts to flatten out, like down here. Not worried about it. I'm not worried about that at this point. What I'm mostly concerned about is that you have your coordinates right, and most importantly, you have your domain and your range correct. And the domain was indeed correct. If this would have been a reflection over the y-axis, we would have needed to look more closely at the domain. So here it's x is greater than 4/3. Had this been a reflection over the y-axis, we would have said x is less than 4/3. So those are things that you need to keep in mind. Reflections affect, y-axis reflections affect the domain with a log. X-axis reflections impact the range of an exponential.